We're going to start looking at the first question on this test. They wanted you to decide which of the following was false. As it turns out, they waited for the very last choice. If you were to go and plug in 5 grams in for the fat and made a prediction, the prediction would turn out to be about 145. But they told you that they observed that the cereal really had 140. So 140 minus 145 should have given us a residual of negative 5 calories. Question 2 was a little bit different. A lot of people got this one wrong. They gave you R equals 0.65 and R equals negative 0.65, and they wanted you to tell a little bit something about it. The bottom line is you really can't tell how strong and which is stronger without seeing the scatter plots. Even curved data could have an R of 0.65 or negative 0.65. So we really don't know until we actually look at the data that we have. Now we're going to look at the third question. And this one is asking you to just calculate the slope of a least square regression line. I want you to remember that the slope is just B1 equals R times standard Y over standard X. In this case, they gave you R was 0.86, standard Y 3.8, and standard X was 2.1. And looking at this, you should have gotten the answer B, which is 1.56. Number 4 is basically asking if you know what R squared means. As soon as they say what percent of the variation in the number of service calls is explained by the linear model, they're talking about R squared. So you needed to be able to just square the R, which was 0.86 squared, which would give you 74. In number 5, they want to know what's true if the residuals show a curved pattern. And this is really basic here. Curved residual means that the straight line is not a good model for the data. This next question is looking to see if you understand what the residual is. Again, Joseph is 22.5 months old and his height is 80 centimeters tall. So his observed height is 80. To get his predicted height, we're going to plug, the 22.5 in for age. And when we do, we're going to get 79.105 about, which is going to leave us a residual of about 0.9. The next question is looking at if you understand the z-score formula for a line. In that case, the z-score of y is equal to r times the z-score of x. They're telling you the speed is 1.5 standard deviations above the mean. That's the explanatory variable. And that the r is 0.6, which means that the z-score of y should be 0.6 times 1.5, or 0.9 standard deviations above its mean. The next question is looking at the correlation coefficient and what it means. They're telling you that R is equal to 0.30. Does that mean that families tend to spend 30% of their food in restaurants or their incomes in restaurants? Absolutely not. The fact, though, that R is positive means that there's a positive association, so the higher their income, the more the families will spend. The last one, the line of best fit, will go through 30% of the data, is just silly. We've never talked about what percentage of points the line will go through. So the answer on this one would just be choice 2, which is C. In number 9, they're asking you if you can interpret R squared. R squared we've always explained as the variation in y explained by the variation in x. So we need something with both variations in it. If you look at choice 3 here, 72% of the variation in profit, which is our y, can be explained by the variation in the amount of spent on advertising, which is our x. So that is the correct choice. It has the double variation. So that is choice A. Question 10 was kind of interesting. I don't have it on here, but they basically gave you that 25% of the variation in what was watched was explained by their variation in reading scores. So they gave you R squared is 0.25, which means that R is either positive 0.5 or negative 0.5. Many of you went with positive 0.5, but one of the sentences said that the study found that children who watch more TV tended to have lower reading scores. That meant that R was negative. Tricky there. The next question was looking at if you could find an equation for predicting the cost of repairs for your car from the number of times you washed your car. In order to start this, we first needed to know the equation for slope was R times standard Y over standard X, which in this case was negative 0.71 times 323.50 over 3.78, which gave us a slope of about negative 60.76. The next thing you had to know is that the least square regression line always goes through Y bar and X bar. So we could set up the equation that Y bar equals the y-intercept plus the slope times X bar. When you solve this, the y-intercept should have become 1344.16. So your final equation was predicted cost equaled 1344.16 minus 60.76 times the number of cars that were washed. The next part asks you to interpret the slope. So for each additional one car that was washed, the cost of repairs went down about $60.76. C asked you about the y-intercept. So when the number of cars washed was 0, we'd expect the repair cost to be about $1,344.16. Part D was asking what percent of variation in y was explained by variation in x, which is the definition of r squared. If I squared my r, I got 50.41. E, very silly boys and girls, can we conclude that washing more frequently will reduce the cost? Absolutely. Watch this. Not. Association does not mean causation. People who wash their cars a lot might just take better care of their cars all around and thus have less repairs. This next one looked at an association between latitude and July temperature. So I would start off A using SUDS and saying the association between latitude and July temperature is linear, negative, and fairly weak. I would also point out that there's one unusual latitude that had a low latitude of about 33 and a particularly high July temperature. The next question asks us to predict the July temperature for a city with 42 degrees as their latitude. So I'm going to take 42, plug it into this equation for x, and you should get about 73.656. The last part of the question asked you to find the residual for Dallas. In Dallas, the actual July temperature was 86, so that's the observed. We need to subtract the predicted. So we need to know for the latitude for Dallas, which is now 32, what would the model predict? So we're going to plug 32 into this equation for x. And when we plug 32 in, we get a predicted of 81.4 about, or 5. So my residual came out to be approximately, when I had my decimals in it, about 4.5. So observed for Dallas minus the predicted for Dallas, which had a latitude of 32 degrees. The last question is asking you to find the equation of the least square regression line. You should be able to look at this and see that the y-intercept was negative 3.822 plus the slope, which was 5.215 times x, which is minutes. And this is going to help us predict the number of floors that were done. Is the line appropriate for this data? Yes, it is. It's appropriate because the residual plot is random. Don't refer to this graph as it or the data. It is the residual plot. The last part of this question asks you if you create a model for predicting the time from the number of floors, what would be the value of r? Well, the first thing you want to note is that switching x and y does not switch r. So basically, they're just asking us for r. R squared was 0.989. When we square root it, we get 0.99. We know it has to be a positive 0.99 because the slope of our least square regression line was positive. If I really wanted to trick you, then we would have had the slope of the least square regression line be negative and gotten a negative 0.99. Hope this helped.